Welcome to Mrs. Miller's notes for her pre-calculus class. These are the notes for section 6.1, day 1, entitled Angle Measures. And today we're going to talk about how we can convert radians to degrees. So we'll talk about those different types of angle measurements. We'll be finding coterminal angles. So we'll talk about angles that are in standard positions. And then we're going to talk about how to find the length of an arc. Now, a lot of this stuff is somewhat similar to what we've been talking about in the previous chapter, in chapter 5, and some of it has to deal with geometry, so this is a little bit of review here of both of those. Here we have an angle, and we have the angle AOB, and as you know, most angles are formed by two rays, and they're going to have an internal angle. And when you're starting at your initial side, your first ray, here we have R1, and you kind of open up the angle until you come to the terminal side, which is going to be R2. And then O, here's our angle, or we're going to call our angle theta. So how much that angle opens and the direction that it opens is basically how far you're moving ray 1 to ray 2's position. So if we rotate counterclockwise, remember, then the angle is considered to be a positive measure. And if the rotation is if the rotation is clockwise, it's a positive measure. If it's clockwise, then it's negative. So that's what they were showing in this previous picture. So if we're opening up and kind of as we go to the left, that's going to be a positive measure because we're going counterclockwise. Here we would be going down and to the left, so that would be a negative angle measure because we're going clockwise. So that's the same as what we've talked about before when we were dealing with rotations around the unit circle. The measure of an angle is the amount of a rotation about the vertex required to move the first ray to the second ray. So I already said that. Intuitively, this is how much the angle opens. And usually we measure this in degrees. Now in a circle there's 360 degrees, so one angle, 1 degree, is 1/360th of the whole rotation around the circle. But when you get to calculus and other levels of mathematics, they talk about radians, and radians are just another way to measure angles. Now, a radian occurs when you have a circle that has a radius of 1. So that's why we talked about radians a lot in the last chapter as well, since we were talking about the unit circle. And when you measure a radian, the measure of a radian is however far it takes to go from the initial point to the terminal point on that angle opening. Okay. Now, when we're dealing with radians, the circumference of a circle of a radius 1 is 2 pi. So to go all the way around the circle is 2 pi, just like on our unit circle. And when you're moving one measurement in radians, you can move 1 radian, or you can move pi radians. You can move pi over 2 radians. So we've talked about pi and pi over 2 as well with the unit circle. Here you can move 2 radians. So usually it's considered to be 2 pi around the whole unit circle. So that's 6.28. If you go halfway around, that's 3.14. So 1 radian would be about there. 2 radians is over here. 3 is just a little bit before you get to pi. So we are able to convert back and forth between degrees and radians. And this is something you've seen before, but we're just going to talk about it more specifically now in this chapter. So in this chapter, there might be times where you need your calculator to be in radian mode, or you need it to be in degree mode. So we'll pay attention to that as we progress through the chapter. But if you have a degree measurement and you want to convert it to radians, then you have to multiply by pi over 180. And if you have a radian measurement that you want to convert to degrees, then you have to multiply by 180 over pi. Now the way I remember this is that if you're trying to convert to radians, then you put the radian on the top of the fraction. You put the pi on the top because pi goes with the radians. If you're trying to convert to degrees, then you put the 180 degrees on top. So let's try a couple of these. If we have a 60-degree angle that we're trying to convert or express in radians, we would start with our 60 degrees, and then we have to multiply it by, and we want it in radians, so I'm going to put my radian measure in the top of my fraction. Because it's always going to be 180 and it's always going to be pi. It just depends on which goes in the numerator and which goes in the denominator. But if you're trying to convert to radians, you put the radian measure on the numerator. Now technically that's 180 degrees. So here the 60 degrees and the 180 degrees, they'll cancel. So the degrees here cancel and the degrees there cancel. So you end up with your radians. And 60 over 180, that would be 1 over 3. So you get pi over 3 radians. And you can just leave it pi over 3, or you can put the little rad behind it for radian. Now for part B, if we're going to convert radians to degrees, we'll start with the pi over 6 radians. And again, I'm trying to get it into degrees, so I'm going to multiply by 180 degrees over pi. So I'm going to put the degree in the numerator. Now here, the pi's cancel, so 180 divided by 6 will be 30 degrees. So that should be fairly simple, fairly straightforward, and somewhat of a review for you, because I know you saw that in Algebra 2. Okay, now when we're dealing with angles that are in a standard position, we can draw them on our x and y axis, or on our plane. The vertex for our angle is always going to be at the center, at the origin of 0, 0. And the initial side is always going to be the right side, or the positive side of the x-axis. And then we're either going to move up and to the left for positive measures, or down and to the left for negative measures. And we basically just draw that opening until we get however many degrees or radians we need to, and then we draw the other ray, we draw the terminal side. And it's good to draw this little arrow that goes around as well, so it's showing direction. And remember, you can rotate around as many times as you need to. So for part C and part D, it shows them rotating several times around. But notice that when part A is drawn and part C is drawn, they end in the same position. So part A has probably only gone maybe 45 degrees, but part C has gone 360 degrees and then another 45. So these two angles are actually coterminal, and we've talked about that in the previous chapter as well. Any angle measures, even if it's radians or degrees, they end in the same location, and they're drawn on the same spot, then they are considered to be coterminal. Now, how we find other coterminal angles then is if you have degrees, here we have an angle that is measured of 30 degrees, and we want to find other coterminal angles to that. Well, if we're in degrees, we're going to keep moving around the circle, and there's 360 degrees in a circle, so you just are going to keep adding or subtracting 360 to that angle measure. And you can add or subtract it as many times as you want. So if we have 360 plus 30, we'll have 390. So 30 and 390 are coterminal. You could also do 390 plus another 360, and that would be 750. So 30 and 390 and 750 are all coterminal. Or you could subtract too. 30 minus 360, that would be negative 330. So if you went clockwise 330 degrees, then you would end at the same terminal point as 30 degrees. Or you could even do negative 330 minus another 360. That would get you negative 690 degrees. So all four of these angles are coterminal with 30 degrees. And we could keep adding 30 degrees or keep subtracting 30 degrees, and we would find infinitely many more. Now part B, this should be familiar. This is what we did in the previous chapter as well when we were finding, coterminal radian angle measurements. We start with the radian measure that we're given. Here it's pi over 3. And one whole rotation around the unit circle in radian mode is 2 pi. So you keep adding 2 pi or subtracting 2 pi. Now this we've talked about before. You really have to think of fractions now. Okay, this is 1/3 plus 2. So when you're adding here, you need a common denominator. So remember, this is pi over 3 plus, see, my denominators would both have to be 3's. So this would be like 6 pi over 3. So 6 over 3 is the same as 2 over 1. Okay, so that's how I would get 7 pi over 3. So pi over 3 and 7 pi over 3, those are coterminal. And we could keep adding. We could add another 6 pi over 3, and that would get me 13 pi over 3. Or if you didn't want to add, you could subtract. You could do pi over 3 minus 6 pi over 3. That would get you a negative 5 pi over 3. Or if you wanted to subtract again, negative 6 pi over 3, that would be negative 11 pi over 3. So again, all four of these angles are coterminal to pi over 3. Now, I just found 4 coterminal angles here. It doesn't tell us how many to find. So read the directions in the book so that way you know if you're finding positive coterminal angles or negative coterminal angles, or one of each or several of each. Okay? But the point is that you keep adding or subtracting 360, or you keep adding and subtracting 2 pi. Okay, our last concept that we're going to talk about for today is the length of a circular arc. And in a circle of radius r, the length of an arc, and they're going to call that S, that subtends, or basically ends, at the central angle of theta is going to be found with this formula. So you have S equals R times theta. So S is your length. That's your arc length. R is going to be your radius. And then theta is going to be your angle in radians. Now remember, if they give you an angle measure in degrees, you're going to have to convert it to radians. And in geometry, you've talked about this as well. In geometry, when we're dealing with arc length, you have the arc length over the circumference, which is 2 pi r, and then you set that equal to the number of degrees over 360. In geometry, you're really focused on degrees more than you are radians. But still, if you're trying to find the arc length, if you're trying to solve this proportion for arc length, you would multiply by 2 pi r. So your arc length is going to be equal to 2 pi r times your degrees all over 360. Now, the 2 over 360, that reduces down to 1 over 180. And then you have pi, and then your radius, and then your degrees. Now, if you look at this, pi over 180, that converts it into radians. So if we have a degree measurement, whoops, switch colors here. If you have a degree measurement that you're trying to convert to radians, you're going to multiply it by pi over 180. So basically then what you would get is you would get your angle in degrees, or I'm sorry, your angle in radians times your radius. Okay, so this formula up here in the top box is the same as what you were using in geometry. It's just a different format. And this little box here, this is just reworking the original formula for arc length so that it is set equal to theta, or the angle measure, instead of being set equal to the arc length. So if you divide both sides by r, then you will end up with this formula. But I know that you can take one formula and rework it so that it's solved for any of the variables. Okay, now what this formula does is it allows us to define radian measures using a circle of any radius. So that's nice. We don't have to just work with a radius of 1 anymore. So no matter how big the circle is, we can find the arc length. And they keep using this word subtends. Remember, that just means where that angle opening ends, where it starts and where it ends. Okay, so let's do example 4 here. But we have part A and B. We're going to find the length of an arc of a circle with a radius of 10 meters that subtends a central angle of 30 degrees. Now, here in part A, they gave you 30 degrees. So you either have to know the radian measure for 30 degrees, or you have to convert it into radians. So multiply by pi over 180. Okay, and that will get you pi over 6. Now hopefully you remember that first quadrant in your unit circle where 30 degrees is pi over 6 radians. Hopefully you know that. And then we're going to find our arc length. So S equals r times theta. And our radius is 10. And now we know that theta, the measure of the angle in radians, is pi over 6. So that would be 10 pi over 6. And then we can reduce that down to 5 pi over 3. And that would be meters. Okay, so that would be the length of the arc that goes around the circle. So for that opening of the angle, that's pi over 6 or 30 degrees, the length of the arc is 5 pi over 3. Okay, for part B now, they give us a central angle in a circle of a radius 4, and it is subtended by an arc of 6 meters. So find the measure of theta in radians. So now we're using the same formula essentially, S equals r times theta, except if we're finding the measure of theta, they have gone through and they have solved this, where they've divided by r. So we're using that secondary formula that they had, S over r. And they told us that the arc length, the S, was 6, and our radius is 4, so then you have 3 over 2 radians for your measure. So that would be 1.5 radians. So that angle, remember if you go all the way up, that's going to be 1.57. So 1.5 would be just a little bit before that. So right about there is where your angle opens. So that's the angle that they're talking about there. Okay, so this should be relatively straightforward practice problems for you. It's very similar to what we've worked with already. I think it's good that we do Chapter 5 before Chapter 6 because Chapter 6 is going to be a little bit easier now. Since you've seen the unit circle and you've dealt with radians, you're a little more familiar with those concepts. Okay, so if this seems very straightforward and you get it, that's a good thing. Remember that the problems are all worked out in the binder in the classroom, but these are all odd problems, so they're in the back of your book as well. And if you have any questions, come on in and see me before school.